Okay, this is known as simplifying or collecting like terms. Okay, so in this question, we have to be able to determine what are different terms. Terms are separated by addition or subtraction signs. Okay, technically this reads 2 times h. So even though they're multiplied by each other, we don't count them as separate terms. We collect it and say it is one term in itself. So there's actually 1, 2, 3, 4, 5, 6, 7 different terms in this question. We have to figure out which of the terms are like terms. And in order to do that, we have to look at the variables. Now, attached to these variables are numbers. Does anyone know what those numbers are called that are in front of a variable? Starts with a C.
Variable?
Command their number.
Coefficient. Okay, so coefficients. When we're combining these like terms are coefficients. These coefficients, we're going to be adding and subtracting them together. But again, we got to figure out which one is a like term. So we look at our variables, and we have to be aware of the exponent attached to it. In order for something to be a like variable, the variable and its exponent must be the same in both terms. So our first example, we'll look at 2h squared minus 7h. Are these like terms? Why not? What exponent is to this h?
1.
Technically, there's a 1 there. So these exponents are not the same, even though the variables are. So these are not like terms. So what would be a like term to 2h squared?
2h squared.
That's right. We have 2h squared, and then we have positive 2h squared. Both of those are like terms. Let's go to our next one. Negative 7h. What would be a like term to negative 7h?
Negative 9h. And negative.
That's right. We have negative 9h and negative h. What's the coefficient in front of that h? Negative 1. Make sure you have that in mind. Negative 1. And we've also missed positive 4h. All 4 of these are like terms. Okay? And finally, this is our constant. There's no variable attached to it, and it's the only constant in it. So it'll be the only thing to not change. Now, we're going to quickly try to do these in our head. 2h and 2h, we're just going to put the coefficients together. What will we get? 4h squared. Great. Negative 7 minus h? Negative 8. Negative 8 plus 4? Negative 4 minus 9. Negative 13. H. And anything happen to our constant? Plus 6. Okay. So, all of the terms we highlighted and colored in combined into 1 term each. Because we found 3 sets of like terms, we ended up with 3 terms in the end of this question. Okay, so our final answer was 4h squared minus 13h plus 6. Okay, number 11. We have a more difficult example. Again, we're going to look at the variables. They must be the same in order to be like terms. And their exponents must be the same. So the very first one, 8x to the power of 4. What would be a like term to that? Positive 4x to the power of 4. Good. Our next one, negative 7x to the power of 3. Any like terms? 2y? Ah, great question. Would the x and the y be like terms? No, because the variables are different even though they are to the same exponent. So those 2 are not like terms. Are there any like terms? There are none. This is the only term that is to the power x to the power of 3. Let's jump ahead to that 2y. Positive 2y cubed. Any like terms? Positive 3y cubed. And then finally, now we got to talk about this. This has 2 exponents. Okay? They're both to the power of 1. Are these like terms? They are. What if this was to the power of 2 and the y was to the power of 2 here? Would they still be like terms? Why not? Because they're on different exponents. In the case we have right now, they are like terms, but you would be right. They wouldn't be. How many different sets of numbers do we have here? Okay, we have 4. 1, 2, 3, and 4. Which means our answer should have how many terms in the end? 4. So let's combine them. 8x to the power of 4 plus 4. 12x to the power of 4. Negative 7x cubed. Anything happen? No, it stays the same. 2y cubed plus 3y cubed. Positive 5y cubed. Negative 7xy plus 12xy. 5xy. And that's it. That's our final answer.